All right, let's see if this stream goes live. Oh, did it work? It looks like it worked. Okay. All right. So in this stream, I'm going to be editing some details and updating some things as I get started here. But in this stream, I'm going to be attempting to build a basic Create React app application to communicate between two computers over DTMF. See what bitrate we can get by just using the speaker and the microphone from the computers, as well as just a web browser running a React app to send and receive some data over DTMF. And so for those that don't know, DTMF is basically just the sound you hear when you launch your phone and dial a number. And so we're going to try to be using that to encode and decode some data over DTMF. So I'll try to play some of that sound right here, so you may be able to hear it. Right, so we'll be trying to use DTMF, which is just that that dialing dial tone, touch tone noises to send and receive and encode and decode some data inside of a React application. So that's kind of what I will be doing in this stream. And I will be updating some of the stream details right now and getting some things set up. So I'll be getting started here in just a couple of minutes. So I'm going to go ahead and update the title, and let's just say okay, so I've just added a description to the live stream with some basic information about what I will be doing during this stream. Of course, let's see, not showing my stream key there. Let's go ahead and post a link to this such that anybody who, how do I, okay, I want to close that little thing up there, but I can't. And so I'm just going to be grabbing some links to this, and then does this auto update? I think it must auto update, right? When I add a description and a title. Okay, let's people and blogs, science and technology, I think is more appropriate. This is a public stream, and I want to get a link so then I can share it with some people that I'll want to share this with. So I'm going to go ahead and go into some platforms and share this with some people who might be interested, and then I will be right back. Okay, so I will bring my screen back up here. Give me 1 second, actually. All right, so let's go ahead and get started here, I guess. I'm just kind of waiting on. Okay, so let's see. I want to. So the goal of this is to be able to create a DTMF-based system for sending and receiving data between two clients using React. And so I'll go ahead and do this so that it'll be easier for people to see the things in the editor. I don't know the quality of this stream, and so please let me know if there are any issues there, and we will rectify those. But yes, so let's go ahead and get started. Essentially, I've just pulled up here a Create React App application such that I can begin coding on this and try to make it work. I've also installed, or I found a really old piece of code from about 2 or 3 years ago on NPM called the DTMF library. Well, it's not really a library, it's just like some code I'm going to try to copy from to get a start here. But I think the first thing I want to do is just delete all the nonsense that starts out when you have a Create React App project, such that we can get a fresh start here. I will delete those. That's going to cause a compile error because there's no index. That's to be expected. And I don't really need to deal with any of that stuff, although I have updated that since I last checked. I'll go ahead and make a new file for the index. And with that, we can essentially start working on this. So we'll want this, if I remember correctly, and then it's just going to be why did I delete the index? See, I'm starting way too, let's see, I just want to insert, so react.render, right? And we want to import our app as well. I guess we'll need to, I would generally like to set up my node path so that it imports things relative to src without needing /, but I think this project is small enough where that's not really going to be required. So now I can go ahead and save this. Is it compiling successfully? It's going to say it's trying to open app.js, which doesn't exist. So we'll go ahead and create that. And let's see, give us some compile errors. We got all that working. Analytics, stream health. No active stream. Did things? Oh no, things are working. It looks like I'm just making sure that everything is everything appears to be working. I will target container not a DOM element. Okay, so I think I've gotten a little bit too I've deleted too many things. We have an element here called root, and we're literally getting that is not. So react dom.render document.getElement by ID root, and we're giving this app. I guess we're going to need React as well. And then we probably, what is it? That? Yeah, I think that makes sense. And that should, oh yeah, we got to actually create the, so we'll get into the DTMF sort of encoding and decoding in a second. I'm just going to set up some basic scaffolding. So we're going to want this, and then inside of here we can kind of just do whatever we want. I think we're going to need async React helmet. No, we don't even have to do that. What am I thinking? We can just do a use effect. Okay, so import React from React, and we'll just export. And this is basically where we're going to do most of everything. This is going to be, I mean, we're not going to do routing in this. There's really no need for something this basic. It's just going to be an encoder and a decoder for DTMF signals, whereby we can type something in. It'll translate it into DTMF and then play it over the speakers. And then on the other computer running this, essentially it's going to be listening and using some code that I found to try to decode the DTMF signals, and then turn those back into a message, right? And then we can see after that we can up the bit rate a little bit, or the baud rate, the transfer rate of data between the systems, and see also what susceptibility there is to noise. We're going to want use effect. We're going to want React. We're going to return this, and then we're just going to put in here like hello for now. As well as something like that. And we'll see about getting this to compile successfully. So still getting an error that the target container is not a DOM element. So perhaps I did not do this correctly. Document.getElement by ID. Okay. Let's see if this works. I should not have deleted that index at the very beginning there. That could have been a little bit useful. Let's just go on. We can figure out exactly where that is and just pull it back in. I should probably know how to do that, but you know. Okay, so we're going to go to the template under source and just look at index, right? So we can, whoops, that's CSS. So we can kind of know what we need to do in order to pull that in. Index.js, and then, I just had it mixed up. That's funny. Okay, we can definitely fix that quite easily. And then, so yeah, we'll just say app. And perhaps this might help us out a little bit in our quest to get this working here. So now we'll go over to this and observe that there is still some sort of I gotta put a lowercase d. All right. This should work better. And there it is, right? We get an alert test because that's our use effect. And we also see hello, so that means that we are indeed not insane, and we can continue to work on this such that, okay, so this is yelling at us for a number of reasons. Are we getting conflicting formatters? We are. Oh well. Nothing I can do about that. I mean, I could change the settings, but that's not something I want to do here. So let's actually get into making something useful. We're going to want we're going to want a couple different things. But I have installed here in Node modules some code which I want to copy such that I can try to get this to work. There's a lot here, but I added DTMF, which is essentially a, let's see, bunch of CSS stuff. It's this old library which I found, and I want to see how well it works. But yeah, we have decode.html, encode.html, decode.js, and encode.js, right? And so if I take a look here at decode.js, we're basically defining some we define an audio context, and then it basically uses get user media, and and then it connects up here, and then there's a every 1 second we analyze this, and then upon analyzing it, it just gets put into the console, right? And so with that, I'm just going to copy this whole thing actually, and throw it inside of our use effect, and we can see how well this works. I'll use my phone to generate some DTMF tones, and assuming this works, of course, because I really don't know. Okay, so this is a new audio context. Is that a function on window? I think that is a function on window, but we'll have to try to find out. So I'll go here and say, yes, it is. Okay, so that's going to say undefined, but it doesn't appear to be. Did it actually give us the? Yeah, so let's try to save this and compile it and see what happens here. We're getting source is not defined and source is not defined. So 17 and 18. We're essentially finding, so yeah, I mean, that makes sense. We can just say let source. And now it's saying that, oh, okay. That should solve those errors. And now we're compiled successfully again. We're getting a permissions request here, which means that something might be working. Oh, it's echoing. Okay, so it's echoing into my microphone, actually. I don't know if this is going to cause any problems on the stream. I think, oh wait, no, you guys don't have desktop audio. So essentially what's happening here is, so you can't tell what's happening, but whenever I speak, it is putting whatever I'm saying back into my speakers, which is a bit unnerving because I have I have one AirPod, and so we'll see what happens there. Let's see if this is still. Yep, we're still live. So we got some stars, some 4s, undefined, 2 right there, 2. I just said the word 2, and it popped up another 2, which is strange. But let's see how reliably this works. So we're getting some erroneous data already, but it does appear to be working in principle on this one device. I'm just going to pull up my phone and make some DTMF tones and see what happens. Let's see. I've just pressed the 1, and it didn't even show up. So there does need to be some changes in order to make this more usable. Let's try some other ones. Huh. Yeah, we don't appear to be getting too much. I mean, we're not getting any data that is accurate. So we'll need, whoops, I just accidentally took a screenshot. Okay, so console.log is not returning any data. It could be that, well, I don't know. Okay, let's look at this. Let's actually read through this and try to understand what's going on here so that we can, let's do that to make that not yell. We'll say analyzers. See, this is really distracting because I have, oh, did it just, okay. Yeah, so this is echoing through my, this is echoing into my speakers, into my headphone at least. And so that's not ideal. I'm going to refresh this and we'll see. Okay, so now it's not echoing into my speakers. The audio context was not allowed to start. It must be resumed or created after a user gesture on the page. So we'll need a start button is what that's saying, I think. Let's just define a function for this instead of use effect, and then we'll use effect that calls that function. Or wait, no, that means, well, this isn't really an effect. It's a thing that needs to happen when the user hits a button. So we'll just say, do we have MUI? We should get MUI as well so we can make things look a little bit cool. Let's just go ahead and add you're gonna add Material UI core. Now we have MUI installed into here. We can import the button and whatnot. And we have this handle start. It's going to say that this is missing some things down here. And yeah, so now we'll need to make a button, which basically says on click equals handle start. And we'll say start listening. Let's go ahead and give this page a little bit of a, no, we don't need to do that yet. So there's a button that basically says, let's start listening, and we'll give it, you know, something to make it look. Variant is contained, color is primary, and of course those have to be single quoted. I'm just used to HTML as all. Okay, so we want to return in parens this such that our tag formatter does not freak out every time. And now that should reliably, yeah, so that's cool. And then I do that to put that inside there. And we already got a warning. Use effect is defined but never used. Okay, well that makes sense. I don't think we actually want to do anything on initial page load. And I also don't think, whoops, I don't think that's necessary now. So we have this function, which is handle start, right? And that's going to do all of this stuff with the audio context and whatnot. What we will need, though, is a state variable so that we can hold, we will need a state variable so that we can hold and we'll also need some typography to show the message. And this is so that we can hold the message that we want to encode or decode using DTMF. And eventually we'll have a text field as well, and we'll have a send button. And that'll be about it for now. And then eventually, once I get this working, or if I get this working, I want to try to send encrypted data between computers after the computers can relay their public keys between each other using ECDH. That would be, of course, probably a little while from now after all this works a little bit better. But now we have a typography which contains a message, and then what we want to do is let's just go ahead and read through this. Basically, function analyze. So analyze is the function that gets called every second, right? Count is 0. Data is a UN data array, which is frequency bin count, and then coefficient is null. Analyzer gets frequency. Okay, so we're basically returning that data, and we're saying for each one of these, and there's a lot of constants here. I mean, we're going to need to make this a little bit better, I think, of an implementation if we want to get it working too well. Coefficient is, okay, so if the coefficient is not null and the count is 2, then we should console.log something, right? I'll probably mess with this later, but instead, in addition to the console.log here, we could say something like pad sub coefficient, right? And so in addition to this, we will set pad sub coefficient equal to that, or set the message equal to that variable, such that in addition to this showing up in the console, it will also show up on the screen, is the goal at least. 44100, so this is essentially saying those are our possible buttons that we could press on the DTMF. Coefficients is 0, 1, 2, 3, 0, 4, 8, 12. Okay. I don't exactly know what all this stuff is, but it looks like these are the frequencies for the different keys. Notes, it looks like keys is equal to that. So we're basically saying, what's the error here? Are these const really? I guess they would be. Okay. So now we have this handle start button, which will do this. I will save this, and I will then, now we have this button, right? Start listening. Now it's started. We don't really have anything in the console yet. I will now try to dial some DTMF again, and we'll see what happens this time. Maybe it'll work. I don't know. Okay. So we did get undefined down here, which means that now it changed to star. So it thought it picked up a star when it didn't, which is strange. But, and again, I'm going to refresh this. Okay, so it stopped what it was doing. And so let's actually read through what this is doing. This is saying here's a context, right? Here's an analyzer for the context. It's saying here's a wave shaper. Here is a gain node. So it's defining some things based on the context, right? Biquad filter. We'll need to look up what all these are. FFT size of 4096. Analyzer. FFT size of FFT size. So then we're saying smoothing time constant is 0. Okay. So I can understand all this stuff. We're saying get user media now, and then everything else down here after get user media. So let's just keep going through here. We define all these variables for the keys and coefficients and nodes and stuff like that. For each note, we need to push onto that, whatever that is, to round those, and then there's our analyze function, and that's it, right? So this should be fairly simple to go through. Let's go ahead and read the get user media to try to turn off that thing that echoes into my ear whenever I put any sound in the microphone. Audio is true. That makes sense. And then the callback is a stream, and then there's error in case for the failure callback, right? So it takes a stream. Source is it's going to get the context and then use this based on the stream, I think. Now we have a source, which I believe, if I understand this correctly, is taking in the audio from the stream. We are connecting that to the analyzer. Yes, so essentially I think this is an audio. Okay, so then we're saying that the analyzer should be connected to a distortion and a filter, gain node, context.destination. I wonder what that is. And then we're saying analyze every 1,000 millis. A couple of variables I'm just going to try to change. Maybe we'll say analyze more often. And then down here, in our analyze function, count is 0. Data is that. We read this already. Coefficient is null. Analyzer.get byte frequency data. And then data is what? That's going to be a length. So however many frequencies there are, we're going to create a new data buffer containing that many bytes. And then for each of the frequency counts in the analyzer, we are going to say if keys contains that, and this is more than a certain value. So if there are more than 150 of those, then we should do it. So it could be that we need to change that number to be lower, right? If the coefficient is null, set it to 0. All right, that makes sense. So plus equal 1. So another thing I'll change is I'll make this like 120, I think. Plus equals, okay, so then we come down after that for loop, and we say if the coefficient is not null and the count is 2, so if the count is 2, then we do it, right? So I think that it could be that this and could either go away or be less. Is this a, see, it didn't do this before, so I'm going to do this just to make this into a string. So that changes some variables. I'm going to hold off on, and then I want to get rid of that destination thing as well on the thing up here, right? So gain node connect. So what if we just didn't connect this to here, right? I don't know what this is going to do. Maybe it'll break everything. Well, actually, let's test this with these variable changes and see if we can get anything working. And then we'll try to disable the audio output. So we'll go started. I will now play some DTMF again. And well, it picked up 7 and star, I guess. Why is it not concatenating them? So it does not appear to be picking things up reliably still. And so I think the conditional down here should be made less strict somehow. So we're taking sub of coefficient. So obviously coefficient cannot be null. That makes sense. But this and, I can just comment out this, and perhaps that'll cause more things to come into the console. Keeping in mind also that this may spam everything. So we're getting more data now, which is cool. Whoops. It's just that there's too much. I think it's being too. Okay, so it's not really picking up. It's definitely picking things up as I speak, but it's not generally picking anything up from the DTMF. It could be that the signal is very weak. I could try to make it louder. Or I could try to make the encode function work, because it could very well be that, yeah, the encode part of this, it could very well be that that is not working because of yeah, and then I really want to make this set message, whatever message was, plus pad sub coef. So that makes sense. We can get rid of all the undefineds by saying, well, no. That very simply. Just, if it's going to be undefined, don't do it. That should work. Count is assigned a value but never used. I can understand that. That makes sense. How does that? Oh, okay. That'll get rid of all the undefineds, at least in the console, if nothing else. And now I think we can try to mess with some of these filter settings. The count is null still. The analyze I call every 100 milliseconds instead of every 1 second, which I think will make it better for higher bitrate stuff in the future. But I don't think that's going to help us right now. And so let's, what we're going to do, we were going to get the encode working. So we're getting the frequency of that data here, and plus I, keys index of I is not -1, and data sub I is more than 120. Let's try to console log data sub I and see what happens. And we'll put this inside of a prefix. Right. And kind of just see what's going to happen here. I'll start it. Data sub I, there's going to be a lot, right? 9, 10. I mean, there's thousands of these. And that's just because of the frequency with which these are happening. We'll see if we can get. Oh, my fan is actually. I think that's a fairly highly expensive computational thing. So maybe I'll do that, because I think that might have caused my computer to crash, or not crash, but come close, or at least the browser. Can I refresh the page? Do I have the ability to do a page refresh? No. Okay. Well, in that case, I will force quit Chrome, and let's not console log data sub I anymore. That seemed like it would be a computationally expensive thing. But I just didn't know how expensive. So there's our local host. Let's make sure that we successfully saved commented out version of this. So basically this is giving us frequency bin count, right? So we're looping through frequency bin count. What is analyzer? When we set up the analyzer originally, context.destination appears to be some sort of a, I think that's the thing that's going to get us to our browser, right? To our headphones. And so I will save this and then reload this and restart it and see if I can hear myself, and also if the things still are going to console log, right? So I just hit start. I no longer hear myself. And I don't think this is going to console log anything anymore, and I think that's why. So I will go ahead and put this back. Now, oh, now I do hear myself, and I do see console logs. We got rid of all of the undefines. So I'm trying to think, why would it be picking up this much data, right? So I'll change the set interval back because I don't think it has enough data each time or something in the buffer. Perhaps that could be it. Right now it's not picking up anything. Oh wait, no, that's why. I hit this, and now we're not really getting as much data, which is still really cool. Let's see if this, yeah, there is still a little bit, but I think any algorithm we use is going to pick up some noise on the DTMF because they are audible tones, and so they are present inside of a person's voice. But perhaps we can get something less than that, right? Perhaps we can find some sequence that once it appears, then it'll start listening or something. Still doesn't appear too much. I think I'll have to come down. So that audio is really coming up very quiet in my speaker compared to my voice. And so I think that for loop is going to need to become far more sensitive. I'll change it to 50. That's going to give us a lot more noise, I think. Oops. So when I start this, I expect more con logs, right? Okay, so I just started it. Anything more than 50 should con log, and I'm not getting any. So maybe it's the opposite. Maybe it's I did get a 6. So the question is, did I hit 6 when I hit 6? I hit a bunch of numbers. I will only hit one number this time and see if we can get it show up. Okay. I think what that actually did is it made it more sensitive. And so, or no, it made it less sensitive, which means that we need to make this number higher. Does that make sense? I was seeing, so we had it at 150 before. We'll try 200, I guess, and see what shows up. Okay, so now It does not really appear to be. Doesn't appear to be showing up as much as we'd expect. When we had this at 150, it was really it would show up with a lot of things, right? It would show up with a lot of different pieces of data. And so now I'm recording again, and this is at 150. And now just during my normal speech, we can tell that it's showing up with more things. And so I guess the thing to test here would be, if this isn't the sensitivity, then what is, right? So if we look here, coefficient plus equals the coefficients of the index and keys of I, why would that? So let's look at keys, because I think keys could be, so I know they defined it as an empty array of here, right? Another thing, okay, so I have a couple things. I would like to look at this as well as the decode, so that we can, or the encode rather, so that we can encode some things using this, because I think that would be cool. Just scrolled past it here. Encode.js. Let's see how complicated this is. So basically, this just defines a function on the window. I think let's just read through this here. And so these are the frequencies that are being played, the DTMF tones, right? So this makes sense. We're simply connecting this and then after 500 milliseconds, so it's expecting about a 500 millisecond tone, I can infer. And then it's also caching the audio context, which is really cool. So this basically defines a function on the window object. Now, instead of defining, so I'm going to copy this whole code, this whole file. Instead of defining something on the window object, I'm just going to define it here, right? So we have encode. A value. This uses some things on the window object. We have our encode function. And now we can try to use this to encode some data. And I don't know if you guys are going to be able to hear this because it's through my desktop audio and I don't have that worked out. Oh, it's just not defined. Yeah, I decided not to use count in the console log. But now I can essentially make a DTMF a dial pad. We'll throw what is it, 12 buttons on that dial pad in a 4x3 grid. I'll define the buttons here. That would be why. Okay. All right. Now we have a 1 button, and it should work. It should dial a 1. I just saved this. We're getting failures to compile because I don't know how to write JSX. Perhaps that might help. Maybe not. Okay, classes is not defined. Of course, I'm used to working on things that have this defined. I will simply remove this for now. We will add some styling if we decide to even release this later. I don't know if I will. So I've just saved and compiled successfully. We have our 1 button here. I'm now reconnected to the context, and I'll hit the 1 and we'll see what happens. It did dial a 1. I definitely heard something. Okay, I don't know if you guys, I don't think you can hear that because it's through my computer and I don't have desktop audio set up. But I did hear a 1. And so let's make a 2. And then a 3, and then a 4. So I'm going to copy this and basically just paste it about 9 times. 3, 4, 5, 6, 7, 8, 9, star, 0, pound. So this is going to be 2, six. Oh. All right. Now we have all the DTMF buttons in the interface. So I'm going to test all of them. So it seems as though we can get one character encoded per half of a second. I would like to, of course, change this such that we can have more characters encoded per half second. And in order to do that, we simply need to modify a couple things. But firstly, this 500. Maybe 250, I think, might be better. 250, and we would say that is false at that point. And then, of course, we would need to change this such that it doesn't last for more than 500 milliseconds. It needs to last 250 milliseconds instead. If it's push return, that makes sense. We just set that down there. We cache our context inside of context. Can we use... no, we can't, unfortunately. Okay, that makes sense. Sample rate is 8,000. Buffer is create buffer. Data is okay. I'm just looking for the variable which indicates. So current time is 0. I'm looking for the variable that indicates. And yeah, you can do letters as well, like C and D. We don't need those. Star before pound. Yeah, that's right. Okay, so if not key map subval, return. So for I is 0, I is less than 0.5 times the sample rate. Okay, so this makes sense. I'm going to change this to 0.25, so that way we inject 0.25 seconds of audio instead of 0.5 seconds of audio into the stream. And according to ITU, I think it's like 0.043 that is the minimum, which is like 5 times shorter than this even, but... Oh, that's funny. Okay, so here's what happened there. I didn't update the second loop because we're adding more frequencies as well. We're combining 2 frequencies, and in order to combine 2 frequencies, it made a 1 and then it made a the second frequency lasted for another 0.25 seconds beyond the first frequency, which of course caused it to fail. And we've just tested, and this does encode correctly. So now we have our encoder for DTMF, and the decoder simply doesn't want to work as well. It's a combination, I think, of echo cancellation and just a couple things that cause this not to want to encode correctly, or no, to decode the heard DTMF values. And then also, yeah, what I don't understand is why this audio encode wants to it's playing in my speaker, right? And so that's non-ideal. Oh yeah, I haven't pulled up the stream here. I will be right back. I'm going to pull up the stream and whatnot. Okay. Oops, I did not turn on my, that might help. Okay. Whoa, that looks really cool. That looks really cool, actually. The zoom combined with the cursor, and it's kind of crazy, but okay. I'll stop doing that and give everyone motion sickness. We have these DTMF. We have all the encode side working. All of those buttons work. In fact, I could add some CSS if I wanted to and make that into a little dial pad. I'm not going to until I know the decode side is going to work, which is the side where we take the DTMF sounds and make them into something that we can work with. So the next phase here, in terms of making this do what we want, is, well, first I'm going to pull this up on something like my iPad, which is hopefully louder, and hopefully it supports the RTC or the audio API. I don't think it will. I'm just pulling this up on my Create React app thing. Okay, so I have it pulled up. The problem here is on iPad, window.audioContext is not a constructor. And so I just tried to hit one of the buttons and it didn't work. And that's because I don't believe audio context is supported on iOS. And another case would be so basically the user needs to go to settings, right? We got to add support for WebKit audio context, I presume. New, so we would say let const. I don't want to overwrite the global though. Call this. All right, so now we have compatibility with Apple's nonsense. Compat audio context. So now we can say new compat audio context. Do I have to capitalize this? I think I should. What is the error? Yes, that makes sense. Okay. So now we have compat audio context on the iPad. Let's see if this... not supported error, the operation is not supported, while calling buffer equals context.createBuffer. So it does not appear as though this is supported on an iPad, which is really, really, really unfortunate for Apple because they really suck. I bet if I go on my Android phone though, if I can find it, since I just switched to an iPhone, ironically, I bet it would work better. So let me go and find my Android phone if I can, and if we can make that working, if we can get that to work, I will be happy. Yes, I have it, and does it have power? It has like 80%, so okay. I will open up my Android phone. It seems so small compared to my new phone. I will turn on the Wi-Fi. I will ensure that this is going to work. I'll go to Chrome and try to pull up the IP address of, yes, of course I have messages. I didn't, all right. I'm pulling up the IP address of this page on Chrome, and we will see if I can make this work on Chrome. Ah, yes, I can. Okay. I hope you guys can hear that on your side, but that is the DTMF tones being sent on Chrome. So it appears as though this stream will actually not involve a computer and an iPad as I had previously planned, but it will involve a computer and a Samsung Galaxy S5 because of the fact that Apple does not decide they want to support the full-featured web audio API, or whatever this is. Yeah, web audio API on their devices. And so that's unfortunate for them, but you know, that's just one less use case for an Apple device. So, okay, we now have this. I'm going to start this listener again, and we'll see if we can get it to pick up DTMF from this significantly louder Android device. It still appears as though we're not getting too much luck encoding things. So that does not do what we expect. I'm going to change some of our decoder settings such that they are, I believe, how they were before. We define this context analyzer, FF size. Well, okay, so to be fair, we need to make this 0.5 again. And this 0.5. And change this to 500. And then come down here and set everything exactly how it was before, right? So we're saying connect all this up, 1000 on that, that's how that was. Didn't change any of these. For each of these, keys push, math round, that makes sense. Const equals that. We need to use count again in our con log. And then did I actually change anything? This is 150 as it was. And then this said count is 2, but I don't see a reason to. Well, okay, so I know I don't want to conlog the undefineds. I'll leave that in, even though it's not what was there originally. And I'll put this back in just because it was there originally. I will save this, and I will now connect this again so that I can start listening and try to get this to run on an Android device. So here goes. Did I not refresh? Perhaps I didn't refresh. Okay. No, it does not pick it up. Perhaps the mic is filtering it out or some sort of problem. I'll try to get this as close as possible here. You're probably going to hear it very loudly, but no, this is not reliable. Okay. I think the next thing is I'm going to try to verify that these are actual DTMF tones. And the way to do that is to call somebody, like with a landline. And I happen to have a landline, so I'm going to try to use this. But using a DTMF emitter, which is this phone here that I've just created, I will try to call somebody, call myself from this landline, and we'll see if we can get that to work. So let's try that. All right, so this did not work because, why wouldn't that work? Perhaps that was not loud enough for the landline to pick up. I'll try one more time, but this is, oh, okay. So it heard a 7. I need to get it to hear a number. And if we can do that, then we can dial. So let me make this into a 3x4 grid such that we can actually dial on that phone a lot easier, because that's a smartphone. So let's say, so in order to do that, we're going to need some styles. And then this is going to take classes. Now we can come down here and say, this is a grid. Dial pad. We're going to need prop types. And we're going to need to find some, what is this called? Oh, we need to call this a thing, const. App equal that. Now we can do there's an object, and we will app with style. And so now we can create a new file called style. And now we can define our CSS. Three columns. .5 EMs, and I think we can tell this to be 10 EMs. And we'll center it. Display block. We're grid, so we're good. Let's give these buttons as well something like variant equals. Oh no. Let's just see what this looks like. Classes is not defined. I thought I defined classes up here. That should work now. Now we have this. What did I do wrong? Let's read through our styling again, just to ensure that we got everything correct. We're saying the width is 10 EM, the margin is auto, display of grid. Yes. Yes, 1FR, 1FR, 1FR. Repeat for 1FR there. This should yield a actual grid, which is cool. So now we have a grid, which is our dial pad, right? Now let's make this look a little bit cooler, just because I think we can. I'm going to change the brightness on our monitor here as well. It's getting, oh shit, it's already at 100. Okay. All right, so variant is contained on these that look like buttons. I'm just going to copy this down 12 times. All right, now this looks kind of like a phone. Kind of, a little bit. Not really, but I want to BR above that, so that way it centers the other guy too. So first off, BR there. And right there as well. And this should, yeah, it puts a space in between those, which is cool. Now I can dial more easily with the actual device. Let's see if I can dial a number using DTMF and have that number receive a call. Nope, didn't receive that. It's got to be like right. No, okay. I don't know if this is going to work as well as I had originally intended, only because the okay. So it appears as though there needs to be some sort of there does need to be a clean signal such that it can be recognized by a DTMF device. Otherwise, it's very, very difficult to encode something, which is unfortunate. I was thinking this would be what did I just do? Trying to dial still here. Nope. Oh. Okay, so I dialed a number, which I don't think it recognized the full number though. So this is not reliable enough, I don't believe, for data communication, unfortunately. At least not with our current implementation. And it was an interesting endeavor to try to get this to work. I can now. Okay, so what I can do here is connect to my. Let's turn this around here. I can connect to my speakers, possibly. And that might permit us to have better luck at. Okay, so I'll disconnect that. I will put this device over here and put this landline back up. Okay, so what I'm now going to try to do is, as one final attempt to get this to work over DTMF at all. Well, let's think. I'm trying to think if there's any other way we could possibly get a DTMF-based here, I'm going to turn my screen off here for a second. So the goal here was hang on here, I'm distracted. The goal here was to try to get two computers to communicate to each other over DTMF, touch tone, basically audio, using speakers and microphones to send and receive text, right? So a message of some kind could have been sent or received via text between two computers. However, some difficulty was encountered while trying to. We were able to successfully encode data using a dial pad, and we were able to successfully, hear some audio across a device, so on an Android phone. it did not support on the iPad. And then I was able to also successfully use an algorithm which was already developed to decode some data or try to decode some audio into DTMF values. However, difficulty was encountered because it was not sensitive enough of an algorithm to be accurate, right? And so that's sort of where I'm at right now with what's happened. I'm trying to think if there's any possible way we can try to accomplish anything more with this, and trying to get it to be useful in some way. We have this dial pad, and so I was also trying to dial over a landline phone and see if the landline would recognize the DTMF tones. It recognized them sufficiently such that the dial tone would be quiet, but it did not recognize them sufficiently to complete a call because of the unreliability of doing so, right? And so that's kind of the conclusion here, is that the technology involved is not sufficient to achieve what we were trying to achieve because whoa, that looks really cool. The technology involved was not sufficient to achieve what we were trying to achieve because of the fact that I'm getting distracted by this. No, the technology was not sufficient because the quality of audio was not sufficient, and so there could be an algorithm written that could attempt to solve this. And so the options here are I could give up, or I could try to write an algorithm or try to understand this significantly better, such that we can attempt to continue messing with it and perhaps getting some sort of audio encode and decode functionality. Now, DTMF is a combination of two frequencies as defined here, right? So for the one, it is a tone at 1,209 hertz and a tone at 697 hertz, and they come together, and then they come out. They send the DTMF sort of frequency. However, I think that there are other interfering frequencies which prevent the audio from coming in clearly at the correct frequencies. Of course, this is the encoder. This is very basic and it works. The decode side is really the one that we want to look at in terms of how can we cause this to work better? What are the technologies involved? So we have audio contexts, which I think we can understand are just a way of accessing audio from within a web page. And then there's an analyzer. So we can look at audio context.create analyzer and see what that does. In terms of looking at what this is really attempting to accomplish with sending and receiving between multiple devices. Here, I'm also curious about these false positives. Why are we getting stars and things logged when there isn't anything like that present? So connect to the analyzer. Okay. I'm just reading through this. So keys is an empty array. And then we're pushing something into it. So we could console log what are keys, right? And this might give us some more insight as well, because it'll give us something to go off of, right? So these are 8 integers that we're listening for trying to understand how that would pertain. Are these ASCII codes? Are these ASCII codes? So I know 65. So I'm trying to think if these are ASCII codes. I don't know what these are. 112. How do we get an ASCII code? So we can make a loop and say something like, zero, 1, 2, 3, 4, 5, 6, 7. Now we have an object containing those things. I don't think these are ASCII at all. So these keys are the things that I'm just trying to wrap my head around. Coefficients 0, 1, 2, 3, 0, 4, 8, 12. Notes are 1209, 1336, 1477, 1633, 697, 770, 852, and 941. So yeah, we define this table, right, where the first 4, so the columns are the first 4 and the rows are the second 4, and then we look at a certain place, and where those two, where the column and the row intersect, that's where the frequency is generated. That makes sense. But what I don't understand is what this is actually doing. We define some constants, hook all that stuff up. We get some variables defined. Pads, keys, notes, coefficients. Count equals 0. So this is a frequency analyzer, I understand, and it's going to give us, it's going to sort all this data and tell us how much of a certain like how much energy was put at a certain frequency, right? And then if 1209, for example, and 697 from up here intersect, then we will know that that is the correct key, right? So for each bin, I don't think this is correct. I actually don't think this is correct because the keys, let's look at the data, all right? So this may crash again. No, we're not running this inside the loop. Just a bunch of zeros. 2048 frequencies. And whenever I talk, more of them will come on board. 130, 165. Okay. 2048 frequencies. Because that's what frequency bin count here is, right? Analyzer.frequency bin count. Let's Google this and just kind of figure out what's going on here. array length is, so get byte frequency data basically is what we're going to looking at, because it get byte frequency data method of the analyzer node interface copies the current frequency data into a uint8 array, unsigned byte array, passed into it. That makes sense. So it's like a biref thing. The frequency data is composed of integers on a scale from 0 to 255. If the array has fewer elements than the analyzer node frequency bin count, excess elements are dropped. If it has more elements, then they're ignored. Okay, so that makes sense. Audio context, and then we're going to say create analyzer. Yeah, it should be the same length, and then we're going to pass it in. The following example shows a basic usage of an audio context to create an analyzer node. Then request animation frame canvas to collect frequency data repeatedly and draw a bar graph for the current audio input. For more examples and information, check out our voice change-o-matic demo. So let's check out their demo that they built. Anywhere to start? Allow. Okay. So this looks to be a map of all the different frequencies, right? And so voice shifting, I can change bass boost, whoa, reverb. That is strange. Distortion. I think I just, all right. Mute. Sine wave. But mainly, that was very strange. It was showing a distribution of frequency for my voice, right? And in the current example, I mean, okay, so I think this is giving us some hope that we can correlate these, right? Because we're looking at this bar of all these different frequencies, and perhaps the two that are related to each other on the DTMF will pop out if I try to play a DTMF tone. We'll see on this graph what actually happens with that. Ah, do you see that? So when I press the star key, it is mapping them, which means that we can see visually that at those two frequencies, tones are occurring, and that means that we're able to programmatically sort of check for that, right? Somehow. I don't know how exactly. I'll try another key and see if it looks different. Do you guys see the difference between those? It's fairly apparent to me when I press 0 versus pressing pound that we can see the two different frequencies, right? So the star, it's really close together. The 0, it's medium, and the pound, it's a little bit further apart on the two frequencies. Same with the 1 and 2 and 3. The 1 is they're close together. The 2, they're a little bit further apart, and the 3, they're even more far apart. Okay, so this does give me some level of hope that this is possible, and I think it is at this point. It's just a matter of getting the algorithm right, but the data is there. It is definitely there. We can see it here. It's definitely possible to do what we are trying to do. Not at a very high bit rate. We're trying to send data between two computers over DTMF. But this, to me, demonstrates that this is possible, right? This is definitely very possible. So here's an example for using the get frequency data thing, which we are using here. I think we're just getting them on the wrong frequencies. We're getting frequency data for, we're not getting 1209. I think we were getting in the low 100s, which makes sense why it would pick up voice data a lot. We're getting a new audio context. Oh, that's a better way of doing that. I was trying to support WebKit. Creating an analyzer. Unit array with the buffer length, and then we're saying, oh, they're drawing something, drawing a rectangle. Based on the canvas and whatnot, but essentially, what I understand about this is we are get byte frequency data method of the analyzer interface copies the current frequency data into a uint8 array. Okay, so current frequency data into a uint8 array, right? So what I want to try to do here, now that we have this data inside of a buffer, 2048 data points inside of a buffer here, is we have this data. Keys.index of I. So I is 0. Oh, so it's the 132nd key. It's not the 132nd frequency. So a key is likely something to do with multiplied by 4. Okay, so that keys thing makes sense to me now. It's basically, we're looping through and we're saying that if there is an index of I inside of keys, and the data here is more than 150. So I think we were on the right track by setting this to 50. Coefficients sub keys.index of I. All right, so coefficients of these keys are defined something like oh, so we're multiplying by these coefficients. 0, 1, 2, 3, or 0, 4, 8, 12, that makes sense. FFT size. So we have to look at 4096 FFT size. I think there could be a max of 2048. Is that why that buffer was not too large? So wherever we defined that as 4096, I think this could definitely help in getting it working if the buffer was not going to be larger than 4096. All right. So now we've console logged those keys. Are these going to be lower numbers now? That makes sense. And let's see what happens when I pull up the Android device. Hang on here. I'm pulling up Chrome on this, and we'll dial some numbers, and we'll see if it works. Still didn't want to pick up. No, it does not want to pick up anything on this, although I would have thought that possibly this is just quite complicated compared to. So let's check to see what the data is here, because we'll see if it's 1024 now instead of 2048, in which case I would be mistaken to have upped the FFT size that much. Okay. It is 1024 now. So it is exactly half of what we want. And that did not work. We can try setting it to 8192 to maybe be more precise, although I don't know what CPU this is going to consume. More precise data here, hopefully, is the goal. We'll see what the keys are, and we'll see what the offsets are. So these are now 4096, and it did calculate keys at significantly higher values. Are we getting any erroneous sort of data? We got a 6. Well, okay. Star. So what I'm noticing is what we can look at here is whether or not it changes, and if so, where, when this data changes, right? I'm really not seeing any data change here, and that's really unfortunate. I saw it on the other one though. I saw the data change on the other device, or no, in the other in the visualizer, right? So maybe we can create some sort of a visualization of this, and perhaps that would work. I would also like to increase the frequency with which this happens. And then to not log this anymore, and not log this anymore, and I'd like to I'm trying to create as ideal of a case as possible for this to work. They had a 255 on that FFT size, so that could definitely be a case. This is 8192, which is double what they had. I'll try 512, I guess, just as a thought that perhaps it will consolidate more frequencies together and therefore pick up less loud of things. Now we could also do a charting thing with Apex charts and just try to try to get a handle on this data. We have an array of values, so we can just pass that in and see how the apex chart thing would look with that. That might give us some indication. Let's try the 512, and perhaps that might work. No, it does not appear to be decoding properly still, and so it really does depend on well, I'm trying to think, what would this depend on? What would this, so that there's the 44,100 is a constant there. We could try 48,000, but I just don't think this is sensitive enough to work. So I think what I'm going to do is mess around with this some more and see if I can get it to work. But I don't expect, well, what would be any, I could try different microphones and whatnot. I'd actually be curious to see if that would work. Do I have another, so I'm using my AirPods right now. I could open my MacBook and try to use that as a microphone. However, I would expect the same results just because the noise level on this is not very high. There's hardly noise to speak of, and so I don't think this will be something we can make work, unfortunately. I'm going to end the stream, and then I will do some further research into this, and if I come across something which can cause this to be more useful in terms of trying to get a DTMF signal from one device to another, and then try to encode data with that, and try to get that data to show up on the second device, and at what bit rate. I think that's an interesting topic to explore, and in the future, I think that I might do another stream about this because it is something that I'm interested in trying to make work. So if you tuned in for this, or if you're watching at a later time, thank you for watching, and I will definitely be doing some other streams in the future talking about programming, signal processing, cryptography, cryptocurrency, and some other topics. So thank you for watching.